Okay, in this session we're going to be covering dividing index expressions. Now just before we start, we're going to just look back at a few facts about dividing. Let's see. If we have 5 times 2 equals 10, we know that we can rewrite this as 10 divided by 2 equals 5, or 10 divided by 5 equals 2. I'll get to the point. The next idea is, instead of numbers, if we have, say for example, 5 times 2x, which is equal to 10x. Now this is the same thing as writing 10x divided by 5, which equals to 2x. Or we could also write it as 10x divided by 2x, and that's equal to 5. So that's just some of things that you would have learned before. So what happens when you have something like x divided by x? Well, for starters, we know that this is x to the power of 1 and this is x to the power of 1, but then any number divided by itself is actually equal to 1, because if you think about it, if you take 7 divided by 7 is 1. If you take minus 42 divided by minus 42, that's also equal to 1, which means, well, x divided by x has to be 1. Okay, on to the next slide. So in the previous session you would have noticed that we did multiplication of index expressions. This time we're going to do division. Now, like any way, you can actually do this the long method. You could actually go x times x times x times x divided by x times x. Now, if you remember from the previous example, x divided by x is actually equal to 1. So what that means is, potentially you could have this and this cancel out to become 1. This and this x cancelling out to become 1, which means you're left with 4 x's in the numerator, which is x to the power of 4. The shortcut method, of course, is when you have x to the power of 6 divided by x to the power of 2 is simply x to the power of 6 minus 2, which equals x to the power of 4, which is the same thing as what we got here. So instead of expanding it out into big, large fractions, we can simplify it just using our basic division index rule, which is just subtract the powers. Okay, let's do a couple more examples. If you have something like x to the power of 7 divided by x to the power of 3, then this is simply x to the power of 7 minus 3, which equals x to the power of 4. Another example is if you have a to the power of 12 divided by a to the power of 7, this is equal to a to the power of 12 minus 7, which equals a to the power of 5. Okay. What happens when you're faced with a situation like this? When you have x to the power of 7 divided by x. Now remember that we did this in the previous session, that if x is by itself, it is also the same as saying x to the power of 1, which means this will become x to the power of 7 minus 1, which would equal, oops, let's try that again, which would equal x to the power of 6. Okay. What happens when you get numbers in front of these variables? So, for example, if you have something like 36x to the power of 4 divided by 9x squared. Now the first thing you really should notice is these two numbers here, there's got to be some sort of relationship. See if you know what the relationship is. But really we know that 9 times 4 equals 36, which means we could really write this 36 in a different way. We could actually write it as 4 times 9, and I'm just going to expand the x's just to show you how this works. Nothing changes about the x's. The previous, see, it's just too long, so why don't we just get rid of all of them and just leave it as x to the power of 4. That divided by 9 times x to the power of 2. Now what you'll notice is, if you remember, we can cancel out the two 9's, because, where can I write this? 9 divided by 9 equals 1. Now if that is cancelled, what you have in the numerator is 4x to the power of 4 minus 2, which equals 4x squared. So that's your final answer. Okay, I'm going to do another example here. So try and do it quicker now this time. What if we have something like 49 over 7, well, let's make this 49x to the power of 8 and 7x. Well, the answer for this, we know that 49 could be written as 7 times 7. So in other words, you have 49, which is 7 times 7 times x to the power of 8 divided by 7x. But also remember, x has a power of 1, which means our two 7's, they cancel out each other, and we're left with 7x 8 minus 1, which equals 7x to the power of 7. Okay, next example. What if we have more than two variables? For example, what if we have something like x to the power of 4, y to the power of 3 divided by x to the power of 3 and y squared? Well, once again, we can expand this, or we just look at the 4 and the 3, and that's the power for x, which means we can rewrite this as x to the power of 4 minus 3 multiplied by y. Now let's have a look at the powers of y. You've got 3 and 2, so that's going to be 3 minus 2, which means our answer is going to be x to the power of 1 and y to the power of 1, which is the same thing as saying xy. Okay, what about when the powers are larger in the denominator? For example, in this question here, if we have x squared divided by x to the power of 4. Now if we write this, if we expand this, we've got x multiplied by x, and all that divided by x multiplied by x multiplied by x and multiplied by x. Now we know that x, the two x's can cancel out, because we know that x divided by x equals 1, which means you can cancel those two out. Remaining behind, remember that when we cancel out each of the two letters, there's a 1 left behind there. And likewise, if we cancel these two x's, we've got a 1 left there and a 1 left there. Which means our answer in the numerator is no longer x, it's just 1 times 1, which equals to 1. So it's 1 divided by 1 times, let's actually do that, 1 times x times x. In other words, this is equal to 1 over x squared. Now some of you might have got this answer here. You might have actually said, where shall I write? It's right here. This is the same thing as saying, because if you actually do x squared divided by x4 can be written as x2 minus 4, which equals to x negative 2. I'm going to show this again in another slide, but what you know, these two things are the same. The 1 over x squared is the same thing as saying, let's try it again. No, it doesn't want to do that. Well, basically, they are the same things. 1 over x squared and x to the power of negative 2 are the same things. So if I do another example, let's do a quick one here. If we have y to the power of 4 divided by y to the power of 7, now this could be written as y to the power of 4 minus 7, which equals to y to the power of negative 3. But we also know that the number there is, where is it? There is 3 y's in the denominator, which means we could also rewrite this as 1 over y cubed. So both of these two answers are correct, but we prefer this answer here. This is still correct. Y to the power of still is correct, but we prefer in positive indices. Okay, going to do another one. What if we have something like 20x to the power of 4 divided by 4x to the power of 7? Well, now, we can start doing things a little bit faster. We know that 20 is 4 times 5, which means we can replace 20 over 5 with 20 over 4. We can say that is 5 and that is 1. Now if you don't understand how I got that, 20 divided by 4 could be written as, I'm just going to write it like this, 5 times 4 divided by, what do we got? Let's actually put that 1 there. And as you can see, the two 4's cancel out, and that's why it's 5 over 1. So if we rewrite this, in the numerator, we have got 5, and then the x is 4 minus 7, which means we're going to end up with 5x to the power of negative 3, or 5 over x cubed. Notice it's only the x that actually moves to the denominator. The 5 still stays in the numerator. Okay, last example for the day. I'd like you to try it if you want, but I'm going to go through it slowly anyway. 6x to the power of 4, y cubed, divided by 3x squared, y to the power of 8. 6 and 3, that could be replaced with, I know that 6 divided by 3 is 2, x to the power of 4 minus 2, y to the power of 3 minus 8. Which means I'm going to get 2x squared, y to the power of minus 5. Now notice there's more y's in the denominator than the numerator, which means your answer is going to look like this. Because y is raised to the power of negative 5, when we bring it down, it will become y to the power of positive 5 in the denominator. Okay, that's enough for this session. Thanks for watching.